Welcome back to this session 7 video, and this is our final session 7 video. And in this video we're going to cover collection interfaces, including lists, sets, and sorted sets, map interfaces, coding to interface, list sets, queues, and maps implementations, iterating collections with an iterator interface, collections, and the enhanced for loop, the Java util collections utility class, and sorting using comparable interface. So the collections interface. So collections in Java is a framework that provides an architecture to store and manipulate a group of objects. All the operations that you perform on the data, such as searching, sorting, insertion, manipulation, deletion, can be performed by Java collections. So a Java collection simply means a single unit of objects. The Java collection frameworks provides many interfaces such as sets, lists, queues, dequeues, and other classes. Array lists, vectors, linked lists, priority queues, hash sets, linked hash sets, and the tree sets. In the next slide, we'll have a look at the classes and the classes that inherit from Java collections, and we will get to see how they all relate to one another in the hierarchy. So here is the inheritance hierarchy. We can see here the yellower is a interface, and the pink is a class. And implements and extends, for the most part, means the same thing, but we could see here a collection. And the collection implements lists, queues, and sets. And we can see here that we now have the array list, the linked list, the vector, the stack. We can see queue, the dequeue. We see set, the hash set, the linked hash set, the sorted set, and the tree set. And we can see how they all relate here through inheritance. So we can see here the supersets through the inheritance, and of course how we can make use of some of the inherited classes and or interfaces. So if we take a look here, we can see the list implementation, and we can see the relationship back to these interfaces, the abstract collection, and we can see here the hierarchy, as well as the interfaces. So we can see the collection interface implements the abstract collection, the list interface implements the abstract list, and we can also, you can see here this type of relationship in the collections framework. And we have talked about these relationships here in the collection interfaces. So again, we can see programming at specific interfaces. We can see these relationships and the implementation classes, array list, linked list, stack, and vector. And we can see here all these relationships. The maps we already talked about. So this is a great graphic that shows the relationships all really coming down from iterable. So here are the list interfaces, and we can see here from list, we can see this relationship here on how the list interface implements the abstract list, and the relationship down from abstract list. Very similar here with set interfaces. So we can see here the collection again, the way it comes down. We can see set, the set interface, the abstract set, and we can see here the hash set, the linked hash set, the enum set, and the tree set that are part of the set implementation coming off the set interface. And it's also, the tree set is also related to the navigable set. We can see something, again, similar for the queue element interfaces. QE interfaces is queue element interfaces. So we can see the interfaces here. The queue and dequeue are the implementation here from abstract queue to abstract list. We can see dequeue and array DQ, priority queue again, and linked list and its relationship to the DQ interface. And remember earlier we said that the mapping is similar to a table. So with a table we have row and column. So there are we need two coordinates or two entries to make a cell in the table. So we have the map interfaces here, so we can see how the abstract map is implemented from the map interface, and we can see the relationship here and how the navigable map implements the tree map. So the array list class declaration, so we can see it here for importing the Java util array list class, and there are three constructors. The constructor, if we don't pass anything, it's used to build an empty array list. If we pass in a collection to array list, it's used to build an array that is initialized with the elements of the collection. And if we pass in an integer, it's used to build an array that has the specified initial capacity. So again, continuing with collection interfaces, there are two ways to traverse collection elements, by an iterator interface or by a for each loop. And if we look down here, we can see that we have a class. We're importing the Java utility package that we talked about earlier. We have our class test collection 2, and we have our main method. Here we're instantiating array list, and we're calling it AL, and we're calling add on AL, so we're adding these elements. And now we're going to loop through these elements, and we're going to be able to return each of these. So let's take a look at the linked list class declaration. We can see here, we can start with these two constructors. We have linked list with no parameters, and that's used to construct an empty list. And if we pass in a collection to linked list, it's used to construct a list containing the elements of that specified collection in the order that they are returned by the collection's own iterator. So let's take a look at the methods that are part of linked list. So we have an add that accepts an integer and an object element, and this is used to insert the specific element at the position of the integer that's passed as the index. Then we have the add first, and we're passing object, and it's used to insert a given element at the beginning of the list. Add last and accepts an object. It is used to append the element at the end of the list. Size returns an integer and is used to return the number of elements in the list. Add with an object that returns a Boolean, a little bit different from this add up here, is used to append the specified element to the end of the list, and then it returns a true or false if successful or not. Contains, and then passing an object is used to return true if the list contains the specified element. So this is contains is searching. And remove with a Boolean that returns a Boolean is used to remove the first occurrence of the specified element in the list. So notice it's the first occurrence of the specified element. So you may have to run it a few times. Then we have get first, and that's used to return the first element in the list, and that obviously returns an object. Get last also returns an object, and it is used to return the last element in the list. These are the methods in the Java list interface. So again, this is the interface, and we can see here how list extends collection. So we have our add, which returns a void, and that accepts an integer and an object element, and that's used to insert an element into the invoking list at the index passed by the integer. Then we have add all, and that returns a Boolean, and that accepts an integer and a collection, and it's used to insert all elements of the collection into the invoking list at the index that's passed as the integer. We also have the get, which also takes an integer, and it's used to return the object stored at the specified index within the invoking collection. So we can see here an object is returned. Then we have set, and an integer, and an integer is passed, and so is an object, and it's used to assign an element to the location specified by the integer within the invoking list. Remove, and the integer is used to remove the element at the position of the index or the integer that was passed in. And we have the list iterator. It is used to return an iterator to start the invoking list, and that returns a list iterator. Now remember that list iterator, very important. These are the methods of the list iterator declaration. So now this iterator that is going to traverse the list, we are going to call hasNext on it. If that is true, that method returns true if there are more elements to traverse in the list. Next, and returns an object. This is a method that returns the next element in the list and then advances a position. So one time we can test if there is next. Sometimes we can test if there is, if there are any elements at all. So these are very, very useful. These have been these types of methods have been used in files to find the beginning of a file and end of file, the next line in a file. Also, the iterator has previous and returns a Boolean. So if true, it's the iterator has more elements when traversing the list in the reverse direction, and then the previous returns an object, and this method returns the previous element in the list and moves the cursor position backwards, or the iterator position backwards. So this is an interesting class example. So again, we're importing the utility package. Our class is book, and you see here we have some data declared. We have a method called book, which takes some parameters here, and we can see here values the parameters. And then we have the class list example, and we have our main method in here. So in our main method, we are instantiating an array list, and we're calling it list. And you can see here we are creating we're instantiating 3 books, and we're calling it B1, B2, and B3. Then we are adding book to the list. So you can see here we're taking B1, adding it to our list, and again our list is right here. And then we're adding B2 to the list, and then we're adding B3 to the list. And again, these objects have all of these attributes, which are name, author, publisher, and quantity. So you can see them all here. And so now we added these books, and now we can traverse them with our for loop, and we can print out each one. So we can print out each. So the B here means the current one that the for is pointing to. So B1 will be the first time, and then it'll move to B2, then it'll move to B3. So it'll print out, if we're just pointing to B2 in this for loop, it would print, this would output ID as 101, and then let us see, and we'll see the author, the publisher, and the quantity all right here. So this is a really good example. Can really pick this up quite easily, and so possibly think about keying this in and running through it. So we have our mapping interface, and again, a map is a two-dimensional, so we have a row and a column. So the map contains values based on that key value pair, and each key and value is known as an entry or a cell, and the map contains its unique keys. A map is useful if you have to search, update, or delete elements based on a key. It's also very, very efficient because we only need that one key to return the value, and we can store a lot in the map interface. The map interface methods, we have put, and we have our keys and our values, and that's used to insert an entry into the map. Then we have put all, and we pass in the map, and that's used to insert the specified map into this map. Then we have the remove and pass in a key, and that deletes an entry from the table. Then we have the get. So the get, notice we're just passing in a key, and it's used to return that value from the specified cell based on that key. contains key, and we pass in a key, is used to search for a specified key from the map. Key set is used to return the set view containing all the keys, and that returns the set. An entry set also returns a set, is used to return the set view containing all of the keys and values. So again, this is a data structure that's often used in shopping cart applications for e-commerce web applications. And again, another great example of the hash map. So we're using the import util package. We have a class called map interface example, and so we can see here our main method. We're instantiating hash map, and we have our map. So we create our map object right here of type map with our integer and string. We have our integer and string, and we're calling put on the map object. So at place 100, we put a meet. We have 101, and we have VJ 102, Raul, and now we can essentially iterate through the map and return some value, so we can see how the data or what data is actually in our hash map. And if we take a look here about the hash map, we can see here the declaration, the class hash map extends abstract map, which implements map. We also see here the class parameters. So the K are those are the keys maintained by the map, and the V are the mapped values. So here is an example very similar to what we saw earlier with our map. We are instantiating a hash map. We're calling it HM. We're putting values into it. Then we're iterating through the hash map, and we're getting the output of the keys and the values. So please take a look at your learning materials. The collections framework are covered more in depth in the materials. Specifically, there are hands-on examples that cover the list, the set, the queue, and the map implementations, and these are taking elements, and the map is taking the key value. Iterating collections with our iterator E interface, and the collections and the enhanced for loop. So let's take a look at the Java Collections utility class. So the Java Utility Collections class consists exclusively of static methods that operate on or return collections. So collections are what are returned. The following are important points about collections. Collections contain polymorphic algorithms that operate on collections, wrappers which return a new collection backed by a specified collection. The methods of this class all throw the null pointer exception if the collections or objects provide to them are null. So if we have any null values, we're going to get the null pointer exception. And if we look here at the class declaration, the following is the declaration for the Java util collection. So you can see here the declaration for a class that extends object, and the following are fields for the collection. So here the static list, empty list. This is the empty list that is immutable. The static map, empty map. This is again the empty map, and that is immutable. And then we have the static set, empty set, and this is the empty set, which is also immutable. Comparable and comparator are both interfaces that can be used to sort collections. There are differences between them. So if we take a look here, comparable provides single sorting sequence. In other words, it can sort the collection on the basis of a single element such as an ID, name, or price, whereas a comparator provides multi-sorting sequences. In other words, we can sort the collection on the basis of multiple elements such as ID, name, price. Comparable affects the original class, i.e. the actual class is modified. Comparator doesn't affect the original class. the actual class is not modified. Comparable provides a compare to method to sort elements. Comparator provides compare methods to sort elements. And comparable is found in the Java lang package, whereas comparator is found in the Java util package. So we have to make sure we import the right packages. And we can sort the list elements of comparable by collections sort with a list method, and we can sort the list of comparator types by collection sort, same thing as over here, but we can also pass the list and comparator in this method. It's another good example here, an application. So you can see here we're importing the arrays using the Java util. This class, interestingly enough, is called main, but we still have our main method. And we can see our car class here, which implements comparable. And we can see here that we have a method here that's part of class. So we have our method, we have our constructor here that we use to build our car, and then we have our compare to method right here. So here we are creating 3 cars. So we can see here the car here, and we're passing in we're passing in the make and the miles. So we have make A, B, and C, and the mileage here. And once we have these cars, you can see here we have our we can print out, and we're calling the compare to. And we are getting, we can also build an array of a car array, and we can pass in the car objects, and we can call the sort on the array. And then finally, we can print out the different cars by looping through, so the enhanced for loop, and looping through each of the 3 cars. So this will first print car 1, or a car A, car 2, and car 3. So key this in and take a look at what we get, and it's an interesting exercise. So this was a long session, but what we learned in this session, we learned about the Java util package. We got our opportunities to use it. We learned about container objects, arrays as containers. We learned about legacy container classes such as the vector, the hash table, and the enumeration, the legacy container generic forms from Java Standard Edition 5, collection interfaces. So we looked at collections, lists, sets, and sorted sets. We looked at map interfaces. We were coding to the interface. Again, we reviewed our list, sets, queues, and map implementations. We looked at iterating collections with an iterator. We looked at collections for the enhanced for loop, the Java util collections utility class, and sorting using the comparable interface. So for our next session, we'll look at threads, and we will cover these topics for threads. Please consult your learning materials. Again, for private coaching sessions for Java, there is private tutoring available for software design and software engineering. Also for private tutoring sessions, private coaching sessions for the Java programming language. Thank you again for watching this video, session 7. And again, this is a presentation of Coding Boot Camps.